Welcome to a session where we're going to discuss how we can convert an analysis that you may have done in Jupyter to a repeatable process that can run within Azure Machine Learning Workspace. Let's imagine that you have an analyst that has created a great Jupyter notebook with some Python code that reads an Excel file and then creates, detects some outliers or does some other analysis on top of the records that are within that file. Imagine that this analysis is for a single company and you want to scale that and repeat the process for more than just one company. And moreover, instead of opening a notebook and running it manually, you would like to automate the whole process. The idea is that you would deploy a couple of resources within Azure that would take care of the end-to-end pipeline. This pipeline would look something like this, where basically you have something like an Azure Data Factory or a Synapse, and then you would have a self-hosted integration runtime that would probably live within your own premises. And from there, it would be copying the artifacts into a data lake. And then on the other side, there would have been there is a pipeline that would read the data and would execute the Python scripts and store the results in a separate location within the same storage. What we will do today is we're going to focus on the AzureML side, and we're going to show you how, starting from a notebook, you can extract a Python script file, which will be executed within an environment and of course, within a compute target, which is going to be our cluster. This cluster is going to be spinning up and down and in order to run our jobs. We will be using a storage account instead of an Azure Data Lake, but the process is very similar in either case. During this video, you will see that we are going to do a couple of things. We will start from a notebook. The first thing that we will do is we will go through it and we will add some parameters so that instead of targeting a single company, we can change those parameters and we can easily target the second company and a third, etc., etc. We will then see all the dependencies that we have, the code, what type of packages our code needs. And from there, we will create an environment which contains all our software dependencies and can execute the script file that we will export out of that notebook. As for the last two steps, we will need to create a compute cluster, which is going to be actually executing our code every time we want to run this process. And the last bit will be creating the actual job that will do the processing. I will start from the Azure portal. This is the Azure portal where I have just deployed a new, in a new resource group, a new Azure Machine Learning workspace. You can create one by clicking over here. You will end up with a couple of resources, including a storage account and a key vault. If I open the newly deployed workspace and I click on the Launch Studio, this will bring me into this experience. In order to upload my notebook, I will have to go over here to the notebooks. And as you can see, I have my user, and this is my username, the user I have logged in. And over here, I can go and upload. I'm gonna click browse, and then in here, select those two files and open them. If I open this, this is a notebook which contains an analysis, and let's see what it does. Basically, it does some imports and installs some dependencies. It then reads the Excel file using the dependency that we just installed. It goes through and installs the PyOD package to do the outlier detection. And then it prints out some rows of the data set. It also creates a couple of graphs, etc., etc. So this, for example, this is a plotly graph where you can get this nice interactive UI. In order to execute this, we will need to create a compute instance because otherwise it's just a static file. So a compute instance is basically your computer in the cloud, and I can just go in and create a new compute instance. I will just need a CPU. I can get something like 4 cores and 14 gigabytes RAM, or even better. I think I will get the 4 cores and 80 gigabytes RAM because I don't have a lot of data, but I prefer the cores. In my case, I don't need anything more special than this. So I'm just gonna click create, and this will start provisioning a compute instance. This compute instance is gonna also be visible over here on the compute side. And as you can see here, it is my compute instance that is running. Let's go back and let's wait until this finishes provisioning. The compute instance has completed provisioning, and I have it over here running. And over here, I have the multiple kernels that this compute instance have. So if I wanted to run everything, what I could do is I could clear the outputs, clicking on this button. I could click on this button, which basically restarts the kernel, so empties all the variables that it has in memory and then starts running all cells. Or I could have just used this menu over here where I could select like run all cells, etc., etc. All normal notebook options exist within this editor that you see over here. In here, you will see that we are using this %pip magic, which is basically installing a package. And as you can see, this is a package that didn't exist within the specific kernel. So these are the dependencies that we are installing, the dependencies that our Python code depends upon. Besides this explicit dependency, there is also another dependency, the pandas and the numpy, which are dependencies that already exist in the Python 3.8 AzureML Python kernel. So these are dependencies that already exist inside our kernel. But especially for this one, we will need to manually install it because it didn't exist in a brand new compute instance. So over here, we're reading the Excel file, and let me show you how this Excel file looks like so that you can understand. Basically, it's a file that has one record per month. So this is 1st of January, February, etc., etc. And it has 14 features. For example, this could be the number of invoices. And what we're trying to do is we're trying to figure out, in this analysis, we're trying to figure out the outliers of this from these records. So that's what we do over here in this piece of code. We read the Excel file and then we print the first 5 rows. We then drop the column date because we don't want that to be part of the analysis. And you see that we are storing this into a new data set. And this is why in here we are using the in place equal false, which means that our original data set, the df one, the one stored in the df variable, will maintain the date column, while the df no date data frame doesn't have the date column. Then we go and install PyOD. We we just import the various analysis we want to do. We create a small structure which stores its model and initializes the model parameters. We just print out to see what type of models we have enumerated over here, and then we do a fitting, and then in the end we are detecting the outliers, and then we go into note that we are fitting on the no date dataset, and the outliers we are storing them in the original dataset df, and then just the model name. So if we print the original dataset that we have, the df one, you will see that it has the date, the 14 features, and then for each of those models, whether it is an outlier or not. And of course, you can create your own complex logic here, like if it's in more than 2 models, then it's an outlier, etc., etc. Over here, we are storing this in the outlier records XLSX. And if I go here on my tree and I refresh it, you will see the outliers were stored right next to the notebook file. And then it just creates a heat map, and basically it is analyzing the correlation between its features. And over here it does the same thing using the Seaborn library, which is another famous library to do various analysis. And over here in the end, we are using Plotly to create this interactive diagram where we can see you can interact with it, and you basically can see the outliers based on the first 3 features. This is a typical analysis that you would want to do for your company A. Now, if you wanted to do this more dynamically, you would probably need to avoid hard coding the names in here, and you would like to have this as a parameter. And here comes the parameterization aspect. So what I'm gonna do is I'm gonna create a new cell over here on the top, and I'm gonna create a new object which I'm gonna call config. This is my config, and basically it's just an object. So I'm gonna, in the definition, in the constructor of this class, I'm gonna create init and then self. So I'm gonna create a couple of properties here. Instead of having a single file, company A, what I would like to have is, I would like to create over here a folder structure. So I'm gonna create a folder structure that I'm gonna call it companies. And in here, inside the companies, I will create multiple folders, one for each company. So I'm gonna have here company A, and then I can have in here, I can create a new folder, call it company B, etc., etc. And now I'm gonna move this file directly inside the companies, inside company A. So I'm gonna move this in here, and instead of naming it company A, I'm gonna just rename this into something more generic, like for example, records.xlsx. Whenever I want to process company A, I will be just pointing my script that it should load the company called company A, and then it would know that the input file name would be records.xlsx. So it would go in here, and it wouldn't go into the company B and load the equivalent file that I would have over there. In order to do that, I'm gonna just create a new variable, and I'm gonna call it, for example, self.input folder, which is basically the /companies1. This is where all my companies are gonna be based. And then I'm gonna create something like a variable that's gonna be called company code, and I'm gonna be using the company A as a company code. So the code will be looking in companies, the companies folder, and then it's gonna be loading the company from company A. If I want, I can also add another variable and call it input file, so that I can explicitly go and read the XLSX file. But this is an optional parameter. I can hard code it if I want. What else would I need? So as you saw, we are storing this outliers records XLSX. What I would love to do is, I would like in the output I would like to store the outputs in a specific folder. So something like output folder. And similar to the companies that I have over here, I would need to create something like analysis /analysis results. I have enough information, and what I'm gonna do is over here, I'm gonna just create a new variable, call it args, and then initialize this class. Let's find the path. So I'm gonna add a cell over here, and what I'm gonna do is I'm gonna create a new variable, call it Excel file path, and this is gonna be os.path.join, and here I'm gonna add args.input folder. So I need the input folder, which is basically companies. Then I want to merge that with company code, and then I want to specify the input file. So if I print this value, you'll see that it points exactly to the file I want to go. It points to input folder, company code, input file. So companies, company A, record A. So instead of having this thing over here hard coded, I can just go and read the variable. So when I want to, for example, load companies B, I can just go here and change this. I can run this cell, and if I print now the new path, you will see that now it would be looking for the files within the company B folder. Of course, I don't have anything, so I'm gonna just rename that to company A, so that again I will be able to load the specific record here. Over here, it complains that the OS is not defined, so I haven't imported. So what I would do is I would probably need to do an import OS so that it doesn't complain. And now the code is done. So with similar, having now this configuration in mind, what we're gonna do is we're gonna go through the whole text and we are gonna optimize, parameterize the whole code. So over here, for example, we have head, which is something that we might not need. Perhaps we will need to remove this as we go into a process where we're gonna fully automate this. Here we install PyOD. We are doing a couple of outlier. Over here, we see that we have, we're writing into an Excel file, and probably what we need to do is we need to have multiple folders, a similar structure, like we said for the inputs, something similar for the output. So what we are gonna do is we are gonna create an output structure, like for example, outputs folder, and then create something like os.path.join, and then I add the arguments output folder, and then also add the company code. So this is going to be our outputs folder where we're going to be storing the files, and then I will be basically I will be saving this into a file that is going to be inside that folder. So I'm going to just do an os path.join, and then I'm going to merge the outputs folder with the Excel with a hard-coded name. You see that I don't need to have everything as a parameters. I will need to add the parameters, the things that really matter to me. So if I run this piece of code, it will actually fail. So if I run it here, you will see that it fails. And if I go down to the error, you'll see that it says that no such file or directory. Indeed, I'm trying to save into a folder structure which just doesn't yet exist. What I need to do is I need to take advantage of a class that's called path, which allows me to create this path. So it's a part of the pathlib module. So I'm gonna just do an import and then path. And what I will do is I will create a new instance of this class passing in the outputs folder. And I'm going to call the makedir method, which I instructed that I want to create all the parents, and it is OK if the folders are already there. So if I just run this again and refresh here, you will see that I have an analysis result and the company. So basically, it created those folders that where I would like to store the file, and then I just go and save the file. And if I refresh again, you will see that my results, my outlier records will be stored here. So with that, we have stored this Excel file, and let's continue. I see over here that we have a graph. So ideally, what I would like to do is I would like to store this this image. So what I can do is I can do a figure.writeImage. In this case, I'm going to use ospath.join. And again, I'm going to be storing in the outputs folder, and I need to save this. This is the correlation plot. So I'm just going to use correlation plot.png. If I wanted to save a plotly HTML file, I can actually do this using the plotly.offline.plot, and then I can save the figure and then specify the file name. If I do a join and outputs folder, and then I name it correlation.plot.html, Now, if I run this, you see that it fails because it starts saying that image export using Kalido engine. So basically, when if I remove, let me comment this out and run this again to see that this is basically where it fails. In order to write an image, I need to install the Kalido engine. And basically, I can do it similar way as we do above. So just do a pip install and then run Kalido. This will install the library inside my Python kernel. And from there on, I can use it within my package. The problem is that if I try to run the code right now, it will fail, telling me again that the Kalido engine is missing because I need to go and restart the kernel. So I will do that. So I'm going to just restart the kernel and run all cells. And basically, I will even uncomment the plotly one because I know I want to save that as well. Over here, you will see that I only have the outliers, but once I restart the kernel and rerun all cells, we will get the images and the plotly HTML file as well. You see that the error went away, so we don't have an issue. And over here, you will notice that we have the correlation plot HTML, which is a very big file. It's 3.5 megabytes. And then we have the PNG, which is 158 megabytes. So perhaps if you would like to automate a report where you would like to share those results with your colleagues, you'd probably be sending a PNG that would have a link to the HTML file that you then would be able to do this magic over here, like interactive things. I'm going to actually fix this name to underscore so that this and this will have the same name. Another thing that we probably don't want to do is if we're going to automate this process, we probably don't want to render this over here, right? So it's useless to have it rendered because we are going to be saving it as files. So what we can do is we can create a variable, something like args.show graph. And if this argument is show graph, then and only then I would like to show this. So what I'm gonna do is I'm gonna go over here into my config and I'm gonna create a new variable that's gonna be called show graph, and I'm gonna set it to either true or false. And basically, whenever I'm gonna be setting it to true, I'm gonna be rendering. If I'm set it to false, I will not be rendering the graph. So if I, for example, set it to false and then run this cell and go over here down to my graph and rerun this cell, you will see now that it doesn't print out the graph, and basically it stores both files over here. So if I go here in the company, you will see the updated with the underscore, and I can go and delete this file to avoid having it in my outputs. So with this, I'm making the whole processing much faster. And I'm also showing you how you can use both Boolean variables and text variables within to parameterize your inputs and outputs. In this one, we have the Seaborn library where we're going to use the safe config file, and basically we're going to follow the same pattern. We are going to just use the args show graph so that we don't render it here. And then what we're going to do is we're going to save the figure using the savefig to the outputs folder and SNS pair plot PNG. So by running this cell, we are going to get the artifacts presented here in the analysis results. We can see here that I made a mistake and I shouldn't have plotted this because we are protecting the show with the if show graph argument over here, but that's fine. I mean, it should work. It's perfectly fine to have it as this. We can potentially even add things like add a subtitle and set the size. like this, where we can set a subtitle and the size, but the idea is exactly the same as we did before. Last but not least, we have this plotly express diagram, which again, it is using the fig.show. So basically, we're gonna copy the code that we wrote above, which is basically gonna write the image that we have, and then we're gonna use the plotly offline in order to store both the PNG and the HTML file. So if I run this, you'll see that it will save the image and the HTML file. And over here, we have the final analysis, which contains all the files that we generated above. So this is the example of parameterizing the whole file. And we can start doing exactly the same analysis for company B by just changing this to company B and then running the whole file again. The next section is about defining dependencies. So what I'm going to do is I'm going to drag and drop all those pip install statements and those OS dependencies from within my file all the way here to the top, so that I can have a clear understanding of all my dependencies. So these are all my dependencies that I have here, and I have a couple of imports. I install a couple of packages, again, some imports, and this is what is going to help me create the environment. Any questions so far?
How are you planning to create this environment?
Let's have a look on the documentation. So if I search for AzureML CLI v2 environment, I am going to find this one over here, which is manage the Azure machine learning environments with CLI and SDK. So in here, there is this repository, which has a couple of examples, which I'm thinking of using.
But why do we need this environment?
That's a great question. With this code specifically, we are installing the dependencies over and over again. So imagine that, and actually what we are doing is we are installing the latest version of OpenPyXL and Calido. Wouldn't it be faster if we had an environment that contains all these libraries pre-installed so that our code can execute directly from there? So instead of waiting for the libraries to install and then execute our code, we already had all those requirements and then we just moved from there. That's the idea. Moreover, if, for example, PyOD changes their API and they move into a new version, which is not compatible with the previous one, your code would break if you were to run this code again in a future version. So having an environment which is stored within your container registry, within the Azure Machine Learning, and you can always use that to run the same piece of code, ensures that your code will keep running even if the library continues to evolve.
So we should find a way how to install all this and create an environment now.
In order to create an environment, we will need to create a Docker file. So I'm going to go into the example that this documentation has, which is this one. And it provides me with two files, a Docker file, which is a very easy to read. It basically tells me that I'm going to be starting from an image that contains already Python 3.8. I'm oversimplifying this. If you would like, you could start from a Microsoft curated image, like, for example, the OpenMPI for Ubuntu 18, which comes with Python already pre-installed. And what it does, it copies the requirements.txt file and then installs these requirements inside that Docker image. I'm going to copy this file from here, and I'm going to go back into my notebooks where I'm going to create a new folder, and I'm going to call it Docker context. This is where I'm going to create my own Docker file. So I'm going to just create a new one, and I'm going to call it Docker file. and the file time is gonna be other. Over here, I don't need this comment. I will be starting from the Python 3.8 version, and if you see here, this is the Python version that I have in my kernel, so this is why I start from there. And I am gonna be copying a requirements.txt file, which I am gonna then be installing. I don't need to delete it. I'm just gonna install the requirements file, and then in the end, I just set a command. So if I need to run this Docker image, I can do. So what this requirements.txt file looks like, let me create that. So I'm gonna just copy this, and I'm gonna create in here a new file that is called requirements.txt file, create. This is a file where I can specify my dependency. So if I go like pip install, it's exactly the same. I'm gonna copy open PyXML, PyExcel, and I'm gonna put it here, or the PyOD file. So I'm gonna add it here, or the Kalido library. Perfect. If I run a Docker build with this file, it would copy this requirements.txt file within the Docker image, and then it would run pip install -r the requirements. So basically, it would go and install those dependencies within that Docker image. Having just the names is not that great, because if I run this today and if I run this same command tomorrow, probably a new version will appear, and I probably get some inconsistencies on my dependencies. So if I go back into my example and see the requirements.txt file that we have inside the GitHub repo, you will see that we can specify the version. In order to find which version you have, there is a very easy trick, which is basically, I'm gonna use pip, and there is a pip freeze, which basically lists all the packages that are installed within the specific kernel that you're running this command. Of course, they are so many. So what I can do is I can just run grep and then open PyExcel, and this should give me the exact version of the code I want. So now I can copy this and I can replace the first line with this. And I can continue doing this with the rest of the dependencies that I have. So over here, I have PyOD, so I'm gonna copy this, add it over here. And then last but not least, the Kalido library. So I'm gonna put it here. And with that, I now have all my dependencies, or don't I? Let's have a better look on the code that we have over here. In here, on the very first statement, we're importing pandas and numpy. These are libraries that come within the Azure machine learning kernel. So the machine that I have over there has a kernel which is running inside a conda environment. If I do something like pip dash version in here and execute that, you will see that it's basically running within an environment that is called AzureML _Py 3.8, which contains a lot of dependencies. When I start from a very fresh Python 3.8 image, I probably won't have all those things. So I will probably need to add a couple more Python packages here. Instead of going down that route, there is another article over here that describes how you can create an environment using a conda specification. So in this example, they are talking about how you can start from a base image. For now, we're going to stick with this approach with a requirements.txt, which is much simpler. It's a very simple file, but you can find an example over here in the environments. There is a conda and YAML, and over here you can see a conda YAML file, which is very similar to the requirements.txt, but it also contains a couple more things.
Andreas, but can't we use the curated environment inside Docker file? I mean, can we start from a curated environment?
You're absolutely right. So that's a great idea as well. What we can do is if we go here into the environments that we have, and for example, search for those that have Python 3.8, we have all those curated environments. What we could do is we could potentially start from over here, AzureML, sklearn, right? So this seems like a nice environment. It's targeting, it's CPU based, so we don't have any GPU requirements or something like that. So that's a great image. It contains sklearn, which is a very basic library, but also probably has all the pandas. We see here NumPy. It already comes with all those packages that we want, and also includes sklearn. And what we could do is we could copy this Docker file, for example. You see that? And here is another way of, instead of using the requirements.txt file, how you can specify within the Docker file what packages to install. Or we could just go in here and copy this, and then go back into our Docker image, and instead starting from Python, we could start from this base image like this. And this means that we would be building on top of this Docker image. I would prefer if we start from a base image, because I don't want, for example, to install in this image. I saw that it comes with Azure Machine Learning Core. So MLflow, telemetry, which are packages that I do not need, or even the Python kernel. So I'm going to start with the Python one, and then we can build from there.
So we can keep our image smaller, and we'll have only what we need.
Exactly. That's also the promise here. To be frank, there are even slimmer versions than this one. This one is a pretty big one. So if I wanted to be super optimized, I'll probably have looked for a very slimmer image as well. Let's find some more. For example, this pathlib library. You will see that this comes here with the pathlib 2. So this is how you would go and you would start add various dependencies. And I already have a list of all the libraries that we need. These are basically all the libraries that we have over here. So the PyOD, all the plotly, Seaborn, etc., etc. So all the references that we have, I just looked up the versions, and I just copy pasted them here. So with that, we have completed our Docker context and the requirements. What we can do is we can go over here into the environments, and we can go into the customer environment, and we can just go ahead and create an environment by creating a new Docker context, or upload an existing Docker context, or you can even select the curated environment and then start from there and customize from there. What I'm going to do is I'm going to do the same thing from a console, from a command line. And the reason is that it's a more repeatable process. And to me, it's easier to do it from a console. If I come here to the documentation, I'm going to just need to create an environment using a build context like this one, for example. So I'm going to come over here and I'm going to create a file called environment.yaml. Environment.yaml. It's a other. What I can do is I can name it somehow. It's the name of the environment that I'm going to use, similar to the Py and all this type of thing. I'm going to call this analysis environment, and perhaps add the Py38 so that it follows the rules of Azure Machine Learning. And then I need to specify where is my build, my Docker context. So basically, my Docker context is the Docker context folder. What this means is that all files that are appearing in here, in this Docker context folder, they are going to be used in order to produce that image. So this is why when you say copy your requirements.txt file, you are referring to this file, which is part of the Docker context. What I can do is I can open a console, a terminal, and I can start running commands. So the very first thing I need to see is whether I have AZ-CLI, Azure CLI, which I do have, and that I also have the Azure Machine Learning extension, and that it's 0.2.5, because everything we have here refers to the version 2 of the CLI. So we are referring to this version. Perfect. So In order to create an environment, you will need to do a command, AZML environment, and then create, and then -f, and then pass the environment.yaml file. If I run this command, it will fail. And let's run it so that you can see how you can troubleshoot problems with Azure CLI. So basically this command failed. And if you see over here, it says, please run AZ login to set up an account. And indeed, in my case, this is a new machine I just created. It hasn't, I haven't logged in with this yet. So I need to run this AZ login. And this will tell me, please visit this page over here and use this code. So I'm going to copy this code and use it over here. So I'm going to log in with my demo account. And yes, I'm trying to log in from the Azure Machine Learning CLI. So this has logged me in. And in here, you will see that in a second, I will be able to see all my environments and the subscriptions that I have. If I do AZ account, so I will see that I am connected, and currently I am connected into my IIT production. I don't want to be in that one because I want to join I want to use another subscription, which is called the IIT TDSP Dev. So what I will have to do is, and this is only in my case, if you only have a single subscription, you won't have this problem that I have. In my case, what I need to do is I need to do an AZ account list to see all my subscriptions, and then I need to go and find the TDSP one, which has this ID over here. And I'm just gonna do an AZ account set, and then that's subscription and this. And now if I do AZ account show, it will have changed to my ID TDSP dev subscription. So now I have a CLI that is connected using my credentials, and it's targeting the right subscription where I want to deploy the environment. So if I go up and reuse the command, what it will do, it's gonna upload the Docker context, so everything that is in the folder, and it's gonna start the building of the environment. If I jump over here to my environments, you will see that it already appeared. And you will see that over here is the context. This is the folder file, which contains the Docker file that we showed and the requirements.txt that we created. And we see that this is the version 1. So I'm going to go back, and you see that over here, it returned to me a couple of more details so that I can have this referenced in the future. One thing that you will notice over here on the environment is that the build status is running. So this means that this Docker image is being built. Behind the scenes, this is built within a container registry that is assigned to the specific workspace. So if I go back into my workspace over here and my resource group, I will see that soon enough, a new container registry will appear, this one over here, which is will be related over here to the container. So the first time that you're going to be building a Docker image, a container registry will be provisioned for you. And within that container registry, you will be able to see the process of building that task over here on the runs. And here is my Docker image that is building. And if you can see here, the very first step that is going to be doing is from Python 3.8. So basically it's pulling the Python 3.8 Docker image, and then it is installing PyOD, Kalido, Plotly, and the rest of the dependencies that we want. And then in the end, it's just pushing the Docker image back into the container registry so that you can keep that Docker image for future references.
Andres, do we have the logs also in the studio, in the workspace?
That's a great question. So if I go over to the build log, you're absolutely right. So here is exactly the same log that is being brought directly here within Azure Machine Learning workspace. So you don't have to go to the container registry to do that. And if you see, it's exactly the same log file. But it's good to know what's happening behind the scenes, from where are these logs coming from. So this is why I showed that. And soon enough, it will be done. We don't have to wait for this to build. We created the whole environment. Now it's time to create the pipeline. The first thing that we need to do is we need to remove those pip install things, because now we have everything installed. We actually, I'm gonna just go and delete those things because we don't need them. I'm gonna just leave this as comment, so that for future version, for future reference, and this one as well. But I'm gonna delete all those pip install libraries. Perfect. So what we are gonna do is, instead of working within this notebook, I'm gonna export this as a code file. And the reason why I'm gonna do this is because it's gonna be much easier for me to execute a code file inside the Docker image rather than running a notebook. There is a way to run a notebook if you insist on maintaining a notebook, and there are open source libraries that can do this for you. For example, you can check the paper mill. So basically, this is a library which allows you to run notebooks and pass in parameters by changing cell values. I wouldn't advise going that route, because although it's been tested, it's been developed for quite a few time now, you get yet another dependency to a library. So if something goes wrong, you have to troubleshoot. It's more difficult to troubleshoot what failed. Was it the paper mill or an incompatibility between the notebook and paper mill? So I'm going to create a new folder, call it code, and I'm going to export this notebook directly in there as a Python file. So I'm gonna edit the location, I'm gonna export it directly here, and what I'm gonna call this analysis.py. So this will bring me with this file, which, as you can see, it's nothing more than the all cells that I have exported as a normal Python file. What I can do with this Python file is I can actually open a terminal in here, and I can run some linting activities. So in order to make this code better and ensure that it complies with my standards and it follows the format that I would like to use, I'm going to use the libraries that we use in our AzureML fundamentals repositories. In here, in this repository, we are advising how you can install those libraries and run Black and Flake against your code. Run the pip install from a console, and it's gonna install them, as you can see here, in the same environment that the notebooks are using. And what I can do is I can actually run, for example, Flake 8 in this folder, and I can see that there are a lot of errors, like expected 2 black lines, missing white space around operators. And you'll say, why would I care? Like this one, for example, missing white space around operators, line 67. So let me show you how line 67 looks like over here. So what this error says is that you have an equal, and it's not like this. It is actually one close character, very close, without spaces. So this makes it more difficult to observe versus this one. So this is what Flake 8 is doing over here. It is first checking the syntax and whether you have missing imports and stuff like that, but it also helps you format the code. Oh, you can see here that it talks about line too long. So what I can do is, instead of going and manually fixing this, I can use Black. So Black is a formatter, which is a very opinionated formatter. And if I revisit this file or reopen it here, you will see that the DF has been surrounded with spaces, the spaces that Flake wants. But it has also changed a couple of things. Like in here, it has changed the the indentation. Like this one was a very big line and it just broke it down, so it's easier to follow through. And now if I run again Flake8, you will see that it just complains for the lines, that the lines are too long, and create a new file, call it setup.cfg. And with that CFG file, what I can do is I can specify a couple of linding rules. So like I can tell it to Flake8 that, you know what, the max line length is 120 characters, and I want to ignore those two exceptions, those errors. And I can do the same for a package that we installed that's called Flake8 Notebooks, which does exactly what Flake8 does for Python files, but it does it for the notebooks. So if I go back and run Flake8, and what we can do is you can see that basically even now within the code directory, if I run Flake8, it doesn't complain because it picks up the setup CFG file and it knows that now it's 120 characters the limit. If I copy one of those dependencies and move them a little bit more down, you will see one more error that appears if I run Flake8. And you will see that it complains that, first and foremost, that the OS is undefined because I moved it below. And the second one is that module level imports are not on the top of files. So this is yet another best practice to move all dependencies up. What I'm going to do is just copy those back and move them all the way up to the top as advised. So black helps me with a lot, but not everything. And then I can go in and I can modify my script to match my style, and I can also add comments and fix everything else. So this is how far the automation tools get you, but from there on, you own the specific code. So now that we have a piece of code, what we need to do is we need to change this hard-coded piece. So the idea that we have is that we will be passing in the parameters so that our code can execute different companies. In order to do that, we are going to use a library that is called argparser. So I'm going to add a dependency here, which is called argparser. And what I'm going to do is I'm going to copy a snippet that I have, and I'm going to put it over here. So what I do is I create a new parser, which is using this library, and I'm defining that I will be having a company code as a parameter, which is going to be the company code that I want to pass. The second argument that I'm going to be putting is the input file, which defaults to record.xlsx. I will be passing the input folder, and I'm going to be storing it into a variable called input folder. I'm going to be passing in the output folder. I'm going to be storing it into the output folder. Note that for those three arguments, I don't specify a default value. While for this one, I specify a default value, and for this one, the show graph as well. So this means that these are kind of optional because they already have a default value. What I'm going to do over here in the end, I'm going to use the parse arguments, and basically I'm going to create an object very similar to the config. So basically, if I delete this right now, input folder will be pointing to whatever input I have specified. So let's run this from a console to see how it looks like. So what I'm going to do is I'm going to open a terminal. So if I run Python and then analysis.py, it will fail because it won't be able to find the input file because we didn't pass any parameters.
But Andres, the idea of what you have done right now is to pass the parameters programmatically. With the previous version of arguments, it was not possible to do it programmatically. This is how I understand why we need this argparse library.
Yes, so two good points. So first and foremost is we now, instead of having a hard-coded configuration object here, which would need to modify the code every time, we are now going to be passing it as parameters. So what I'm going to be doing is I'm going to be using this flag over here, company code, and then I'm going to specify company A. And then I'm going to also need to specify the inputs folder, right? So input folder. And for the input folder, I'm going to specify that it is the /companies. And for the output folder, I'm going to specify that it is /analysis results 2. So input folder, output folder. For the input file, I don't care because it will get the default value, which is records XLSX. And for show graphs, I definitely don't need that. So the default value of false is perfectly fine for me. So now if I run this, you will notice that it reads the records from the specific folder, and then it fails that company A records XLSX doesn't exist. And that's true because I am in the code folder. So this doesn't exist here. So I have to go back and I have to do 2 dots. So basically I want to read the files from the parent folder. So let's run it again. And you'll see that now it's located the company A record XLSX file, which is on my parent, and then inside the company A. And it will start, if I refresh here, you will see that it already created analysis result 2, company A, and then it started outputting those results that I would like to see. So this is how I would run this from a command line, and I can now dynamically run this as company A, then company B, company C, etc., etc. Another thing I wanted to point out about the code is that if I go through it and read it, I'll see this Excel file. That's fine. That's for debug reasons. That's okay to put there. But for example, this code over here doesn't make any sense because I'm just using the head function, which doesn't print anything because it is not an interactive notebook. If I wanted to print the head, I would need to change this code to print df head. And then I would be outputting into my console something so that I can see in my logs. I can remove this head again. No need to have this. For example, I can even remove the show graphs. It doesn't make any sense to keep it because I'm never going to be showing graphs. In order to run this analysis, what I'm going to do is I'm going to create a pipeline that we are going to use. Let's get an example of how to do this from our docs. So I'm going to follow a similar approach to here. This is about creating a machine learning pipeline with components with the CLI v2. But in our case, it's not. We are not going to be training anything. We're going to just be executing this piece of code, passing in different variables. In order to, this is a typical YAML file that defines a pipeline, and you will see a couple of things in here, like for example, a display name and a description, or the compute where this pipeline will actually execute. This is the compute cluster that is going to execute the code. It's going to pull the environment that we created, and it's going to attach in there the code that you have. It's going to also attach any other files that you need, like for example, the Excel files that we need, and then it's going to execute that code. So let's grab this piece of code over here, and I'm going to create over here another file. I'm going to call this company analysis pipeline .yaml, and this is other. So I'm going to just create this, and I'm going to start with the example that we picked, and I'm going to start modifying it to match our type. So on the top over here, I'm defining a schema, which is a pipeline job. This will help things like Visual Studio Code or any other editor that I'm using to be smart about the completion. For the display name, this is what's going to appear on my executions, and I'm going to just call this company analysis. I'm gonna put a small description here, like a pipeline, and I'm gonna also pass in the experiment name. So every time that I execute this, all my executions are grouped under a specific experiment. I'm gonna call this, for example, notebook to pipeline. And over here we are referencing the CPU cluster. So this is a compute that will be spinning up. It's going to be executing the piece of code that we have, and then it's going to be shutting down. If I go back here to my computes, I currently have a compute instance. And as I mentioned, this is my own personal compute instance. I could use that, but then I would need to come in and manually start the compute whenever this pipeline would run, and then close it down. So this is where compute clusters comes in handy, because they have a great feature that is the auto scaling. And what I'm gonna do is I'm gonna create a new dedicated machine. I'm gonna use CPU based. I'm gonna use the specific one, or I can, which is a great option actually. I can change it to something else as well. So for example, I can grab a similar one to the ones I have, or this one over here, the 2 cores and 7 gigabytes of RAM. That sounds like a nice option. And I'm gonna call it CPU cluster, the same name as my script has. I'm gonna specify that I will need 0 nodes whenever it's idle. So I don't want to be paying for that machine if it doesn't run anything. And I want to have a maximum of 1, which means that I will be able to be running a single job at a time. If I wanted to run more works, like parallel run company A, B, C in parallel, I could add more nodes. Or if I leave it to 1 node, I will be able to schedule the A, B, and C companies, and they will be queued. And when the processing of company A is done, the processing of company B is gonna take place, etc., etc. So it's a matter of whether you need that concurrency or not. In my case, I'm gonna just use one, and I want it to be able to scale down after 120 seconds of idle. So if I don't push for a second job, I'm gonna it's gonna just scale down. Let's go back into our pipeline, and over here we can specify inputs and outputs. In this file, I can only see outputs. Let's create some inputs as well, and I will start with inputs like this. And basically, I'm gonna create a variable that is called a parameter that is called company code, and I'm gonna put a default value of company A. So basically, I'm creating a pipeline which will be getting as an input the company code. So whenever I'm running this pipeline, I can specify company A, company B, etc., etc. So this will allow me to modify which company to process. For outputs, I can just create the output folder, and I can use something that is called a type, which is missing right now. It's a URI folder. So I'm going to create an output variable that is called, that is going to be mounted as read write. And basically, I will be able to add files there. And I can even specify a path. And I can tell it, you know what, I'm going to be using Azure Machine Learning. So a resource that is attached inside my workspace. And if I go over here to my data stores, I will be able to see these are the data stores that are already attached to my workspace. And here is, for example, the workspace blob store, which is the default storage account that I can use. I can browse it here. And this is, if I come over here, this is my storage account in the containers. You will see that this is AzureML blob store. And in here, you can see the local upload folder that we saw here. So what I'm gonna do is I'm gonna go back into my storage account, into the storage browser, and I'm gonna visit this blob container, and I'm gonna create a new folder here. I'm gonna call it, I'm gonna create a new directory, call it companies. And within that companies, I'm gonna create a new company A. I'm gonna create a new folder called company A. So now I can see it here, companies, company A. And what I'm going to do is I'm going to upload here the file that I have over here. So I'm going to upload this after, but I will rename it to records.xlsx so that my script will be able to find it. This is a process that normally you would be doing this through Azure Data Factory. You would be using Azure Data Factory to upload the latest records, and will be landing it inside the blob store or your data lake or something somewhere else. So if I go back into my click refresh, I will see that I have companies, company A and record. So I want my script to be able to access this. And this is a path that I can use like this. I can tell it path, Datastores, pass, and then put the name of the store. And then I need to add the word paths because I need that word. And now I can specify this is an output folder. So in my case, I want to store inside the same folder. Instead of having companies, I want here to create a new folder that is going to be called outputs. And that's all I need. So I just created an output variable that is a folder. It will be mounted with read-write permissions. And the location of that is going to be within my data stores that are attached within my workspace. Inside my default data store, that's the name of that I picked from here. It's going to put inside the outputs path. I could also create an inputs folder here so that I can modify that. But in my case, I'm going to show you something different. What I'm going to do is I'm going to hard code the path, the inputs inside my component. So let's start with here. We need a job, and a job has a couple of steps. I don't need the rest of the steps, but if you want, you can make it multi-stage one, and you could be using outputs from one component, one step to be accessed for the second component, etc., etc. We have a great documentation which can help you if you want to see how that works. In my case, what I'm going to do is I'm going to create a single step over here. I'm going to call it analysis. And the type is command. I'm not going to use a component, so I'm going to use command directly. So what I'm going to do is I'm going to specify that my code is located inside the /code. So /code. Here's where you'll find my code. The command that you're going to execute is going to be Python, and then I'm going to copy it from here where we run this command. I'm going to just copy this and bring it to my. So this is the command I want to run. So I want you to upload the whole code that is located in this folder. And I want you to run analysis.py, which is the file that I have here. And for the company code, here I want to use the input. So what I can do is I can basically directly reference parent.inputs.company code. So this means by using this, I'm basically referencing my parent and then the inputs and then the company code variable. Or if I want, I can create here my own input. So I can create a company input, which is going to be bound to my parent company code. And then I can specify in here, instead of going to my parent, I can specify that I'm going to be using my own company code, this one over here that I just created. So I can company code, I can name this company code from component. So that it's clear that now I'm going to be referencing this one. Why would I want to do this? You will see later that when if you bind this directly into the pipeline, then this piece of code is less reusable, because what you could do is you can register this thing over here as a component, and then, as I said, you can use it through the designer by drag and dropping it. So basically, by exposing those inputs and outputs here, you can bind them then later to other components and drag from one component to the other and do this type of thing. So this is why it's a better practice to do it like this. As for the inputs folder, I'm gonna, again, I can use the same structure as I use for the output folder. And over here, I can specify like input folder, and then I can specify that the type is URI folder. I can again bind it over here into my pipeline, or if I want, I can just bind it over here directly inside my component. So I'm gonna use again the same path, but this time instead of aiming for the outputs, I'm gonna be targeting the companies folder. So companies. So this is gonna be my input folder. And then in here, I'm gonna replace $ and then inputs.input folder. And for the outputs, again, I can bind it directly over here to outputs output folder, or I can create a new output variable like I have over here. So my output folder in this component, and I will name it from component so that it's clear. It is bound to my parent output folder. So like this, and then what I need to do is I can replace this output folder by binding it to the components now output. So outputs dot output folder from component, and now I have this is bound to my this variable, which is bound to my company A pipeline variable. My input folder is defined only on this component, and it's hard coded to be on the specific companies folder. I could take this and move it here so that I can then bind it again. Or the outputs folder, which is another great example, it's bound into the outputs folder, and then I'm using it over here. So this is a simple pipeline which contains of a single step. It has 2 inputs and 1 output. I haven't specified anywhere where this code will run, and this is done over here through a parameter which is called environment. So in here, I need to specify which environment is going to execute this piece of code. And since we registered this over here into my environments, I can actually just call it. So I'm going to copy this and go in here into my notebook. And I can tell it that, you know what, I want you to run this using AzureML and then semicolon, the name of my environment, and I can use the notation of latest, or I could just bind it to version 1. I'm gonna just use the latest. So let's run this inside an Azure CLI. So in order to execute this file, I'm gonna run AZML and then job and then create and then pass a file which is gonna be analysis pipeline. You will see that it uploads the code. So basically, these are the artifacts that you get uploaded, and you will see over here that it created a pipeline that will appear over here inside my jobs. Note that the experiment name is the notebooks pipeline, the one that we use. So if I open that experiment, I can find all the executions that I have. And the display name of that job was company analysis. So this is the name that will be appearing. And here is the pipeline that we just created. And as you can see, we have over here the various inputs and outputs that this component has. So this is the output from component. And in the parameters, we should be able to see company code from component. So this is the input parameter that is coming in. And I see also that the data companies, this is an input that is hard coded inside this company analysis. So this is the component, and this is why I specified as an input parameter only the company name. and nothing else. And I have hard-coded the input, but the input is, of course, hard-coded into a space that is within my Azure Machine Learning workspace.
Now that the analysis has finished, I can go in the logs and I can have a look on my output, and here I can see the data frame that I was printing and the various methods. I can also go into the overview and I can open the environment, so I see that this is the version 1, and of course I can see the bid log, and over here I can see all the requirements that my code used in order to execute. And this is the beauty of the environment, that everything is baked in that image. I can navigate back to my experiment by going over to the pipelines, and from there selecting directly the pipeline job, which is called company analysis, and this is how I can end up back into my executed pipeline. If I were to go back into my requirements and remove one of my dependencies, like the Calido one, which we know causes an issue to the execution of the code, I can create a faulty environment so that we can demonstrate how to troubleshoot similar cases. So this is an experiment that runs.
As you can see, the process failed, and we are going to explore the logs to figure out why this has happened. So just a heads up, I have modified the pipeline so that the pipeline is using the wrong environment, as you can see here. So what I'm going to do is I'm going to click on the component that has failed, and I'm going to navigate to the outputs and logs. And in here, I can see the STD log under the user log. And in here, I will be able to find that in the track back, I see that image export uses Calido engine required for Calido package. In the analysis, you will also be able to find the code. So in here, you have a piece, the code that executed for this job. The .aml ignore file, you will find it in multiple places. It's a file that the editor is creating, and it tells Azure Machine Learning what files to ignore. Like, for example, the temp and the TMP files that are automatically generated by the editor while you are editing those files. Once I have a pipeline that executed, what I can do is I can resubmit it. And when I click resubmit, over here, you have the ability to actually change the company code. So this is how you can then request the same process to execute for company B. And what you can do even further is you can actually go and publish this. So what you can do is you can create a new pipeline endpoint. So let's call it company analysis. That's fine. We are going to publish the company analysis and then the date. This is the date when this analysis run. And we're going to set this as the default pipeline for this endpoint. So every time you're invoking this endpoint, this pipeline that we have registered here is going to be executed. And the default value for company code is going to be company A. So once I click publish, what it will do is it will take me, if I click here, it will take me down over here to the endpoints, to my endpoints, pipeline endpoints. And basically, this is a pipeline that has a REST endpoint over here, which I can invoke either through a REST client or through an Azure Data Factory. And basically, I can trigger an analysis. So if I go back here to my pipelines, you will see that here I have the 3 executions that I had. This one was the one that failed because I was missing a package. This is the one that I ran the first time, and this is the one that I published. Over here in the endpoints, I created this company analysis. And now I can go and just click submit. And from here, I can request, for example, company B to be executed. I'm going to use an experiment where I want to run this pipeline, or I can create a new experiment just for the triggered through pipeline. So I can group all those executions under the same context, and I'm going to just submit. Of course, it won't be able to find pipeline number company B, but we will see what happens. So now a pipeline has executed. So this is an endpoint, and what we just did is make a REST request to enable to trigger this pipeline execution. And again, if I go back to my jobs, you will see a new experiment, the trigger through pipeline that is being created. And I can see here my company analysis running. So you will see over here that it's gonna read, it got company B as an input. So now what it's gonna do is gonna go over here in AzureML blob store. It's gonna look on the companies folder in company B, and it's gonna try to read that Excel. And of course, this file doesn't exist, so the whole process will fail. Which is over here, and I can see that it failed. And again, I'm gonna go inside my outputs and logs over here. And I can see in the std log that basically no such file. And you will see that it is trying to load an endpoint, and in there, it's gonna try to find this folder, which is basically mount into my companies folder. And then it's gonna try to find company B and records XLSX, which doesn't exist. Let's go back into my pipelines and let's execute once with company A. So I'm gonna use again the trigger through pipeline, company A this time, and I'm gonna submit it to show you that it's gonna work. And I'm gonna go here to the details, which opens me a new window. And you can see immediately that the analysis completed, because basically nothing changed. So Azure Machine Learning is smart enough to understand that this pipeline has executed. So it won't re-execute it again because no parameter has changed. If I wanted to force the execution of this pipeline again, I would need to change something, like, for example, an input or a folder, or perhaps, or another approach is I will need to go back into my company analysis over here and specify that the output of this analysis is not deterministic, which is something that will allow me to rerun the same code multiple times and force the execution over and over. In order to force the pipeline to rerun the specific command, we will need to move this code inside the command component. And if we go back into the article where we started from, you will see that over here it describes how this command component schema looks like. And if you see it, it's nothing more than a command, an environment, the code, and the inputs and outputs. It's exactly the same thing that we have. So let's go back into our notebook, and we will create a new component in here, which I'm gonna call it, this is another, and I'm gonna call it company analysis.yaml. So this is a component that we're gonna create, and on the top of this file, I'm gonna add this schema definition and that it's a command line, and I will just copy the rest of the code from here and move it over to my command analysis over here. So the first thing I need to do is, let me do a shift tab so I can bring it a little bit closer. I'm gonna put the code. Where is the code? This is the command that we are gonna execute. This is the environment, nothing changes. What I will change is that over here, instead of binding things to the parent pipeline, I'm gonna change this and I'm gonna type in that, hey, this is an input and I'm expecting here a string. For the input folder, I'm gonna change it, and instead of specifying the paths and everything, I'm gonna just specify that this is an input again, but this is gonna be a path. So this component is gonna expect for a path to arrive. Same as here, we are gonna need an output, and in this case, again, this is gonna be a path. So these are the basics that we need to specify. If we want, we can specify the name and display name. So I'm gonna put those here, and the name is gonna be company analysis, and the display name analysis of the company. Perfect. So with that, I can go back into my pipeline, and in order to keep that, I'm gonna just duplicate the specific file like this. I'm gonna name this company analysis with component. So I'm gonna edit that file, and I'm gonna keep the same thing here, type command, but instead of specifying the code and everything, what I'm gonna do is I'm gonna specify the component here, and I'm gonna be pointing it to the /company analysis. And now that I realize I should probably rename this to company analysis component so that it's clearer what this refers to. So I'm gonna name it like this, and I'm gonna copy the name here as well. I don't need the code, I don't need the environment, everything is specified in inside my component analysis, but I do need the inputs and the outputs. And basically, I'm gonna leave them as is. So basically what I'm doing is I'm taking those inputs and I'm binding them now to the inputs and the outputs of this specific component. I will save this and I will open a command line and I'm gonna execute this. So AZML job create Joseph, and I'm gonna use the. So this triggered the execution of this job. If I go back to my analysis, I will see that a couple of things changes. So here is my new component with the display name here, and I can go into the overview. I can look at the results and everything, but nothing has changed. I mean, of course, the code changed. So this is why Azure Machine Learning is executing this pipeline again, but nothing. Once it's finished and then I rerun it, I will get exactly the same effect where I will be having a cast, I will be using a cast output. So if I publish this, I'm gonna override the endpoint and visit my company analysis and run this from here. Again, I'm gonna select triggered, company code A, and run this. I will see that if I go back into the details, it will run almost instantly because basically no input has changed. In order to help with this process and be able to reuse the same pipeline, what I need to do is I need to go to the component that I created, and over here in the beginning, I'm going to use a property that is documented here, which is the isDeterministic. So I'm going to use isDeterministic and type false. And with this, I'm forcing the pipeline to re-execute this every time, this component, because the output of that component is not deterministic. So I'm just going to create yet another job with a new definition that we created. And if I go to the job details, I will see that of course, we changed the code, so it is expected that this will run. This will execute once more, but we will notice that after we publish this, every time we will be triggering the published pipeline, it will be constantly executing over and over again. So the pipeline executed, I can go ahead and publish this. I'm going to override the default step and finish. And now if I go back into my pipelines and the pipeline endpoints, I can just go and submit. From here, you see that it has been updated. And I can click submit. And now if I trigger this once more and go back here, I will notice that the pipeline is waiting and it's gonna execute as expected. You see that it is executing, it's taking more time. It's not instant as the previous thing. So with that, we have covered the end-to-end scenario where we took a piece of notebook code, we curated a little bit, we created an environment, we show how we can troubleshoot missing dependencies and how we can go back and create a bigger environment with more dependencies to be able to run our code, how we created a component which we determined that we specified that it's not deterministic, so that we can force the pipeline to re-execute all the time instead of running once and then reusing the stale inputs and the stale outputs. And in the end, we have the files like stored within the default storage account in the outputs in the company A. Here are the results that are outputted, and you can see that time has changed and all of those files have been replaced exactly because this pipeline executed.